Good morning, afternoon, evening. Today will be the first day in the last unit of our polynomial graphs, sine graphs, sinusoidal graphs, and graphing in general. So it's a graphing type unit. We kind of do like parts of two chapters here. This will be our final unit in Math Foundations 30. Okay. And we're going to be using Desmos as well, which is an online graphing program throughout the unit to look at graphs and see what the shape is like and things like that. Okay, so let's get started today by looking at kind of what we're going to do in the first day. Okay, in terms of what we're going to do for the full unit, we're going to be looking at polynomial graphs, kind of what they do and what their basic shapes look like and the characteristics of them, which is basically equations of powers of x. And then we're going to be looking at sinusoidal graphs, graphs of cosine and sine, and how they shift and change. And then we're going to be looking at just general plotting graphs, linear graphs, quadratic graphs, and even cubic graphs a little bit with the help of Desmos and extrapolating and predicting. And that's basically the whole unit, those three areas. What we're going to look at today is the first part of polynomial graphs. So this is day 1, unit 4, and the final one that we're going to do this year. Some of you may have seen this if you've taken some of the other maths already. I know that my people in Vanguard here have covered most of this stuff in parts of it anyway in Pre-Cal 20 already, so they've got most of what they need for polynomials and some of the sine and cosine stuff. But they didn't do too much regression, linear regression, and line equations, but that does come in grade 10. So it's not a brand new unit. Okay, and what we're going to do day 1, I guess unit 4, we're looking at graphs. So that's polynomial. Sinusoidal. And also the basic graphs. Oh, I guess they're linear. There we go. Okay, and what we're going to be doing today is pretty simple. We're going to, first of all, we're going to define terms for polynomial graphs. Okay, and then we're going to, after we define the terms of the polynomial graphs, we're going to be looking at the basic first, I guess, 4 types of graphs. In pre-cal, you look at the first 5 or so, looking at the shapes of the first 4 kinds of polynomial graphs. Okay. And basically, I think that's as far as we're going to get today. And we're going to use Desmos to help us out here. So I'm going to get that set up. So if I just bring over my course here, okay, and we just go to an empty tab here, and we're going to go to Desmos. Okay, Desmos online graphing calculator. Okay, this is what we're going to use. You can get it on a Chromebook, no problem. Okay, it's a web-based graphing calculator. And this is what we're going to use to help us graph the equations. So you can follow along and use it with me if you like. And that's what I'm going to be using. So I'm going to put that over here. And at times we're going to pull that out and use it. Okay, so the first thing is we got to get some definitions down and kind of how things work and what we need to know and all that kind of stuff. Okay, so let's start off with basically the degree, a polynomial function first. Oops. Right on the wrong side here. Let's get on this side. So polynomial function. Okay, graph that has powers of x written in the form and the form of a polynomial is f of x equals or y equals, and I'm going to use y for most of the time. So if we have y equals or f of x equals, and then we go a x to some power n plus b to x to some power n minus 1, and then plus c x to some power n minus 2, and so forth. Okay, where a, b, and c are numbers, or integers if you like, and n is some power. Let's call it, well, it's also integers. Okay, so what does that look like in reality? So y equals 3x cubed plus 8x squared minus x plus 7. Okay, there's an example. Okay, now you don't have to have all of them in here. You might have some missing. You might have 4x squared plus 9. Or you might have 9x cubed plus 3x squared minus 8. And so these are all polynomial functions. Okay? Or sometimes they're written as f of x equals negative x cubed minus 3x squared plus 7x. Okay? So those are examples of polynomial functions. Okay? Now the degree of the polynomial function is the highest power of x in the function. Okay? The degree of a polynomial function is the highest power of x in the function. Okay, so for example, okay, if you have y equals 4x squared minus 9x plus 3, this is degree 2. Okay, because of the power of 2. Okay, y equals x cubed minus 7x plus 8. This is degree 3. Okay, we always go ascending order of x's when we organize it, but sometimes if it's written like this, 3x plus 9x squared, this would be degree 2, because this is still the highest power of x. Okay, so that's what degree means. Okay, leading coefficient is the next thing we'll look at. And that's the number in front of the highest degree in the polynomial expression. So leading on. Okay, I got to spell that right. I think I've got too many. There we go. Okay, the leading coefficient. This is the number in front of the highest degree in the polynomial equation. So for example, on that one, leading coefficient. So if I had y equals 4x cubed minus 3x plus 9, the leading coefficient is 4. Okay, f of x, that's another way to write it, equals negative x cubed plus 6x squared minus 4x plus 1. Okay, doesn't look like there's anything in front, but if there's nothing in front, we assume there's a 1 there, so this would be a negative 1. So the leading coefficient here is a negative 1, because that's a negative in front, so we can say it's a negative 1. Okay, so whatever's in front of the highest power. Okay, so the other thing that we need to know is we need to know what an x-intercept and a y-intercept are. Okay, we'll do this on the next page, I think. Okay, so if we take our Desmos over here, we'll just kind of write that down later. But let's just draw a typical polynomial graph. So how does Desmos work? So here, if you get to Desmos on your desktop, here where the wrench is up in the corner, you can change how big your x is. This goes from negative to positive 10. This one goes from and the y-axis goes from negative 6 point something to positive 6 point something. It's good enough for us. And if you're doing trig graphs, which we will later, you can either put it in radians or degrees. But right now we're just doing regular ones. You can put the grid out. You can have arrows, whatever. Okay, so let's put in a graph. Let's put in a typical polynomial. So you don't have to put in the y equals because it does it for you. Or you can if you want. It doesn't really matter. I'm going to put the y equals in just to show you. Y equals. Okay, and then we're going to go, let's go 3x squared. So 3x, okay, and then to go to the squared, you push the caret button above the 6 on your keyboard. So that's shift, caret button, and it moves it up. Okay, or you could click it on the bottom there where you see the keyboard is. 3x squared, okay, and then push my arrow key forward so that it comes down, minus 4x plus 2. Okay, I don't want to put a space there. Plus 2. Okay, so there is my graph, and we're going to change it a little bit as we go. Okay, so this here, where we're talking about in graphing, a couple of things we can talk about. We can talk about this part right here, the vertex at the bottom. This, where you have this kind of behavior, is called a turning point. You'll notice that if I put a cube in here instead of a square, so I go back and I put in a 3, you can see now that there's 2 turning points in the graph. There's one there, there's one there. Okay, if I put a 4 in there, okay, I can't quite see it because I got to zoom out here. But that it kind of looks like a flattened one. Let's zoom back in. That one's not a great one. If I put a 5 in there, okay, it has a couple more turning points. And if I throw in a few more expressions, so let's say I put 3x to the 5th plus 2x to the 4th, okay, minus 4x squared. Let's put a squared in there. Oop, not an at. Squared. Okay, and 2x here. Okay, and minus 5. Okay, so you can see that there's a lot of, if we zoom right in here, there's a lot of weird stuff going on down here, but there are some turning points going on. So we don't have to go all the way up to x to the 5th. We go up to x to the 3rd. Zoom back out here. Let's go 3x to the 3rd minus 2x squared okay, so we can see, so that this here are called turning points. Okay, where it crosses the x-axis is called the x-intercept, and where it crosses the y-axis is called the y-intercept. Okay, let's put a minus 2 in here. You can see that our y-intercept goes all the way down to minus 2. Our x-intercept in this case is like 1.161 or something. Okay, and there's a couple of turning points here. Okay, so let's throw a few definitions down. Let's go put this over on the side here. Go into the next page here. Okay. Okay. So an x-intercept is where the graph crosses the x-axis. Okay. And with this, y equals 0. Okay, and we'll just put that in brackets. Y equals 0 at the x-intercept. Okay, and along with that, a y-intercept is where the graph crosses the y-axis. Okay, x equals 0. The y-intercept. Okay. Okay. A note in here: a polynomial graph can have a maximum of x-intercepts equal to its degree. So that means something to the third power can have 3x intercepts. Something to the second power can have 2x intercepts. Something to the first power only have 1x intercept. Something to the fifth power can have 5. Not always will it have the same number of x intercepts. It can have up to that many and less. So x squared can have 2x intercepts or 1x intercept. X to the cube can have 3x intercepts or 2 or 1 or even none, depending on if it's shaped underneath the y or x or the x-axis. Sorry, guys. Okay, so another thing about a polynomial curve, a polynomial graph can have a maximum number of turning points equal to the degree minus 1. It's degree minus, so x squared would have 2 minus 1 up to 1 turning point. X cubed would have 3 minus 1 up to 2 turning points. X to the fourth would have up to 3 turning points, and so forth. Okay, so that gets us through x-intercept, y-intercept, whether you have how many x-intercepts you can get, how many turning points you can get. We also have what a degree is, okay, as well. Okay, so the other thing, let me just double check here. Oh, end behavior. We also need to know what end behavior is. Okay, end behavior for a polynomial graph. Let's see if I can spell behavior right. I'll have to look it up here. Where is it? Behave. Okay. If we're talking end behavior, we're talking about, for a polynomial graph, it's the shape of the graph from left to right on the edges, on the left edge and on the right edge. Okay, the shape of the graph, well, it's any graph, I guess, but we're looking at polynomial one specifically. Shape of the graph on the left edge of the graph, on its left edge, and right edge. Okay, so if we bring back this graph that we had up here, and we get rid of this keyboard out of our way, the end behavior of this graph is, here's the left edge. So the end behavior of this graph from left to right is that it's climbing up. From left to right, as we move along the graph this way, it starts down low and it goes up high. That's noted as the end behavior. If I put a negative in front here, it changes it. Okay, so the end behavior is flipped. Okay, it's starting up high from on the left and going down low on the right. Okay, if I put in let's throw in a fourth power there. Okay, notice that it's starting low and finishing low. Okay, for that one. Okay, so that's the end behavior, the edges of the graph. Okay, let's put that back over here. Okay, end behavior of the graph. Okay, the last thing, or a couple more things, not last thing, I guess there's 3 more things, is to look at the what the domain and range are of a graph. So domain of a graph are all the values of x the graph has. And range of the graph is, of course, are all the values of y a graph has. There's domain, range, turning points. Okay, turning points is where you have a U shape or an N shape on the graph. Okay, and turning points. We should probably put down what a turning point is. I didn't really define it, did I? I just said how many you could have. Okay, so we'll just throw in what a turning point is as well. See if I missed anything here. Turning points is a point in the graph where the function changes from increasing to decreasing, or from decreasing to increasing. Okay, so a turning point is the point in the graph or on the graph where it changes from increasing to decreasing or decreasing to increasing. Okay, visually, I always say you kind of get a U shape or an N shape. Okay, that's kind of what it looks like. So, okay. Again, in our graph over here, that's a turning point because we have an N shape in the graph. We take this and put this back to a 3 like we had it before there. Okay, there's kind of a U shape there a little bit, and then an N shape kind of going down there. So there's a turning point and a turning point. Okay. Okay. The other thing, and I should put in there, is odd or even function. Okay, that's pre-Cal 30 stuff, is where we really talk about it, but still we need to know it a little bit in foundations. Okay, I'm going to move this up because maybe my face is in the way. I can't tell anymore with the preview as it's changed a little bit. Okay, and the last thing I'm going to talk about today for definitions is an odd function, polynomial function. Okay, this is the degree of the function is odd. An odd number. 1, 3, 5, so forth. An even function. Polynomial function, sorry. Okay, the degree of the function is an even number. 2, 4, 6, so forth. Okay, so that's all the definitional type stuff we need. Let's check out, see where we are in timeland here. How much okay, we used up a good 30 minutes there. So let's do a couple minutes here of just looking at, and we'll save the types of graph for tomorrow. Actually, we can probably get the first one or two done. Okay, so let's start off with a first type of graph, degree 0. Okay, we're going to do degree 0, degree 1, degree 2, and degree 3. Okay, those are the first four that we're going to look at. And that's probably as far as we look in terms of foundation study. If you were in pre-cal, you would do a lot more than that. Okay, so let's start off with degree 1 or degree 0 polynomial graph. Okay, degree 0 polynomial graphs, the first thing that we can say about them is that they're called the constant function. Okay, these are called constant functions. There is no power of x because there's 0, right? So it's y equaling a number. Okay, there's no power of x. The basic form, the basic equation form, is y equals a, where a is a number. Okay. Okay, and these graphs form horizontal lines. Okay, and the end behavior, okay, the domain and range of these graphs, okay. Domain is all values of x. From negative infinity, positive infinity, and the range is just a. Okay, so the range is y equals a. It always has to equal a, whatever that number is. Okay. There's no turning points and there's no x-intercept except if it's y equals 0, then it's right along the x-axis. No turning points. No x-axis, x-intercept. Except for y equals 0, which is the x-axis, and the y-intercept is equal to a. Okay, whatever that number a is. Okay, so what does it look like? Oh, the end behavior, we should do that too. End behavior from left to right is a flat horizontal line. And from left to right. There's a summary of it, what it looks like. So horizontal doesn't have an I in it there, sorry. Okay, so it just looks like this. If we graphed it, y equals 3, or we could have one down here, y equals -5. Okay, those are constant functions. Okay, no turning points, no x-intercepts. Domain is all x's. Okay, we have arrows on both ends, obviously. And the range is whatever the value of y is, and that kind of thing. So that's the first one, y equals that. So if we could throw it on Desmos, but it looks pretty simple. Like we throw it up here on Desmos, just get rid of this stuff here. Put a number in there, 6. Oh, that's way too high. There it is. Y equals -3. There it is. So that's the constant function right there. Pretty straightforward function. Okay. Okay, we'll do one more and then we'll finish up the rest tomorrow. Okay, we'll do the linear function because you're pretty familiar. So we did degree 0. Okay. Now we'll do, on the next page, we'll do degree 1. So degree 1. Okay, these are called linear functions. Okay, they're called linear functions. Okay. Now, if we kind of look at it, first of all, we'll say it's, let's do a sketch first and then do all the sum. Well, yeah, then we can do the summary beside it. So if I'll do a sketch right here. So a linear function, we'll do 2 different colors. It can go like this or like this. Okay, so this is y equals ax plus b. This one here is y equals ax, or -ax, pardon me. Oh, sorry, I got this, pardon me, I got it backwards here. Let's fix this one. This one's ax. Okay, this one's climbing, so it's positive. Y equals ax plus b. This one is negative here because it's going down. The leading coefficient, okay? So you can see that the power of x is 1. Okay, so if we summarize these, and then we'll stop after this one. So let's go here. No, I need to go there. Okay, so summarize. Power, the degree equals 1. So a is the leading coefficient. Okay, if it's negative, the end behavior goes down from left to right. Okay, sometimes in grade 10 you used y equals mx plus b. That's where m was the slope. Okay. Okay, goes down. Say goes down from left to right. So another way to put that is the graph starts high in quad 1, or quad 2, sorry. And finishes low in quad 4. Okay, so the quadrants, if you don't know the quadrants, they're labeled like this of the Cartesian plane. Okay, this is quad 1, 2, 3, and 4. Okay, the opposite is true for the blue line. Okay, if this doesn't really sound that clean here. It says A is the leading coefficient. It says if A, the leading coefficient, or when. Better when A, the leading coefficient, is negative. Okay. Well, and then the opposite is true for the other one. If A is positive, behavior climbs from left to right. Okay. Okay. And we can say that it starts low in quad 3, and finishes high in quad 1. Okay, that's the end behavior. Okay, there's no turning points. Okay. Domain is all values of x. Range is all values of y. Okay, we have one x-intercept and one y-intercept. Okay, for that, and we could stop at that. I think we'll have to stop there because we're running out of time. We'll do the other two next day, okay, because we're into about 43 minutes, so we'll stop there. Let's just look back here for a minute if I missed something. Domain, range, turning points. Okay, it's an odd function. Degree 0, let's go back to degree 0. Basic equation, we got domain, range, turning points, and behavior. Okay, so we're good. We got a little sketch of it. Oops. Okay, so we'll stop there today, and we'll do degree 2 and in 3 tomorrow.